In this video, we'll discuss testing for React components and applications. We'll investigate various types of testing strategies such as unit testing, integration testing, and end-to-end tests before discussing Jest, a testing framework from the open source team at Facebook. In our discussion about Jest, we'll discuss snapshot testing and functional testing with respect to React components. Let's begin. Building resilient and error-free software is never an easy task. You have a ton of components and services that work together, and if something breaks down, it can have rippling consequences across the application. That is why testing is integral to software development. Testing is defined as a process that evaluates if a software performs as per its intended design or not. Every industry, as a matter of fact, employs testing strategies to ensure quality. For instance, cars are tested for safety as well as for performance, fuel efficiency, and pollution norms, among other things. Television panels are tested by rendering patterns and then capturing the output using special cameras and sensors to assess reproduction accuracy and consistency. Coming back to software, React apps are no exception. With several components, services, and functions all working together, there are always chances that something might not behave the way it should. And since software development is teamwork, it is only prudent that all deliverables pass essential quality checks before they see the light of the day. This is why test-driven development is a time-honored and proven way of building resilient and maintainable applications. And typically, there are three major types of testing strategies at play when dealing with computer software. The first strategy is known as unit testing. Unit testing aims to test individual components in isolation. For instance, a toggle button React component can be tested to see if it works as advertised or not. Likewise, a component that displays formatted currencies can be unit tested individually. In fact, this is what we do when working with React. We unit test React components because we are essentially building features as components which act like Lego blocks in the context of a large application or a product. Unit testing ensures that your components and their behaviors work exactly as intended before it goes into the product. For instance, when building a component that validates credit card numbers, the unit test can be designed to attempt a variety of numbers to see if the validation logic holds ground or not. In doing so, you can test error messages thrown by the component, the outcome of validating both correct and incorrect data, and even vulnerability tests to assess security prowess. The second strategy is known as integration testing, where multiple components are put together and tested. For instance, a payment form with components to enter and validate credit card numbers, amount, and security code. Integration testing aims to test features that are put together using multiple functional components. The core purpose here is to test behavior and coherence. The third and final strategy is known as an end-to-end test. While unit testing assures that every component works as intended, an integration test assures multiple components work together harmoniously, it is also important to test the final application from the point of view of user behavior. An end-to-end test involves simulating user interaction and behavior. For instance, to test an application's login mechanism, an end-to-end test will simulate keying in a username and a password and hitting the login button and then following up to see how and where the application leads to, followed by more behavior and interaction. In doing so, we can simulate a number of possible conditions in an automated manner. For instance, what happens when only the username is entered, or when an incorrect password is keyed in, or an XSS vulnerability test which tries to inject executable code into an exposed form to assess how it is handled. And when correct credentials are used, does the login flow lead to the right destination page or section in the app or not? Now, when working with React, we'll focus our attention on unit tests because we are dealing with components and unit tests are more relevant in context than full-blown end-to-end tests. We'll also explore integration testing in the process. But let's go back and answer a very fundamental question that you may have if you're new to testing. What exactly is a test and what does it look like? In a nutshell, you begin by writing a test suite, which is a fancy name for code written using test runners and utilities that are designed for software testing. A test suite consists of groups of tests. For example, for a component that displays weather data, you could have two groups of tests, one which assures that the component renders without errors, and one that could conduct multiple tests on individual elements of the UI, such as displaying the correct icons, temperature units, and other visual features. Once you author these tests, you run the test using the test runner, which executes your test instructions and gives you a success or failure report. You might be tempted to think that this is a burden. In order to test code, you have to write more code. Well, that is true to some extent. The benefits and extra work involved in a test-driven workflow far outweighs the cost of putting out untested code in the wild. In the React ecosystem, the most common software that you would use for writing and running your tests is Jest, a simple but powerful testing framework that can be used not just with React, but also with Angular, Vue, Node.js, and more. Jest is very easy to understand and offers an expressive API that makes your tests readable. Now, usually Jest is used in conjunction with test utilities, which allow you to simulate a test surface, such as a browser DOM, giving access to virtual DOM selectors, nodes, and other elements that simulate component behavior in a realistic manner. The React DOM library comes with built-in test utilities that can work with Jest to set up a test service and simulate a React application. Similarly, React Testing Library is another popular suite of tools and utilities that can be used with Jest for testing React components. Yet another popular option is Enzyme from the open source team at Airbnb, which offers a jQuery-like interface to let you find DOM elements in a simulated setup. Jest, on its part, provides the syntax, structure, and utilities to help you author test suites easily. Let's look at a quick example of Jest in action. Here I have an empty folder, and we'll begin by setting up an npm project since we'll need to download Jest. So let's say we want to write a function that ingests an array of numbers and computes an average. I'll create a file named computeaverage.js where I'll build and export my function first. This is what we want to test now. So we'll download Jest as a development dependency. I'll now create a file named computeaverage.test.js. This will be my test suite where I can author my test and expectations. So we'll import the computeAverage function first. Then I'll write a test using a test function where I'll describe in simple English what the test will achieve. In this case, we will attempt to compute an average of this array of numbers and the outcome should be 3.5. We'll then use the expect statement which sets an expectation where we'll invoke our actual function with the given conditions and we'll use a matcher function called toB, setting it to 3.5 as our expected outcome. If you read this statement, it should be abundantly clear what this test is trying to achieve. This is the beauty of Jest. This is all we need. Now, to run the test, I'll just invoke Jest on the command line from the node_modules/.bin folder, and it reports that my test has passed with flying colors. That is how you test your code in a nutshell. Now let's try to change our input a bit. And our test fails. Your goal is thus to ensure all tests pass. Now, in the context of React applications, one of the core features of Jest is snapshot testing. A snapshot, like a photograph, captures the rendered output of your code. This is stored on disk as serialized HTML or even as JSON if needed. When you run the test, Jest can compare the current rendered output with the snapshot on disk to compare if they're same or not. The test passes if they are the same. If your UI is expected to show you the same consistent outcome given a set of fixed conditions, then snapshot testing is great. For instance, if you've updated internal logic in a component which is not expected to result in a visual change on the UI, you can perform snapshot testing to ensure your UI continues to deliver a stable and expected outcome even when internal code has changed. If snapshot testing breaks, then you know something's not behaving as it should have and you can assess the problem. Snapshot testing is thus great if your UIs have to be consistent and are not going to change in the face of a given set of evolutionary updates to code. It guarantees visual stability and predictable outcomes. But snapshot testing is not always suitable, such as when you want to test specific functionality of your component, rather than what it renders under a given condition. In such cases, a functional test is more suited. Here, we can test actual functionality such as event handlers, state mutation, and even API calls. But one core thing to remember here is that instead of testing implementation, we test its outcomes. Testing internal logic is an incorrect way of testing components, which is why test runners like Jest are designed to help you test outcomes, the end result which the user sees and interacts with. Ultimately, you are testing from the point of view of users and their behavior. A functional test will typically render a component in a simulated environment and then go on to perform a series of simulated user interactions. For instance, for a login component, the test could involve keying in a username, a password, and clicking the login button to see if the form makes an API call or not. If the component was designed with built-in validators for username and password, then the test would succeed if the API call is made. This API call can itself be mocked so that the test simulates an API endpoint rather than using a live one. This makes it really easy to create fully testable components even if they involve querying APIs and services. In this module, we'll take a look at examples of unit testing React components using test utilities from the React DOM library, Enzyme, and the React testing library. So let's begin by the test utils from the React DOM library in the next video.